Okay, so chapter is conic section. Okay, so basically this is a right circular cone and it is defined as the cutting of the right circular cone with different angle relative to the axis, and this is the axis and this is the base. Okay, and the shape obtained on the surface on the cone are known as conic section. Okay, in which how the conic section is generated by the different curves are obtained. These curves are will be ellipse, parabola, hyperbola. Okay, and sometimes it can be from circle, point, straight line, or intersecting line. Okay, so this is the right circular cone. This is 90 degree, and remaining the angle is 45, maybe 45 or 60 30. Okay, so these lines, these lines are called as end generator. Okay, okay, and this line, this backside line, which is marked as saddle line. Okay, and this lines, this line are generator lines. Okay, and this is our right circular cone. Okay, this is our ground or base in which the cone is mounted. Okay, next we have to select some angle. Okay, this angle between two opposite end generator is denoted as 2 theta. Okay, and this angle is called as apex angle. Okay, these are the terminology you have to remember. Okay, and this from middle to this end generator is angle is theta. Okay, it is symmetrically. Okay, two opposite end generator angle is 2 theta, and from this middle to this end generator is angle theta. Okay, so we select some cutting plane in which the cone is to be cutted, to be cut. Okay, let's the cutting plane cut the cone at some angle, and okay, this is the our cutting plane, cutting line. In this view we can see only line. In 3D view you can view the whole plane. Okay, these are the whole plane in 3D view. Okay, this line cut the our cone in some angle, and what are the terminology you have to follow. Okay, so this angle is denoted, let's beta, and the cutting plane makes angle to the our uh, midpoint is at angle phi. Okay, and this end generator or end generator make an angle with the base alpha. Okay, so this is alpha, this is beta, and this is theta, and this phi. This is very important terminology you have to remember, and by the help of this four angle we can generate ellipse, hyperbola, parabola. Okay, so this is the 3D view, and in next page we can see the 2D view. Okay, so that you can understand very clearly. Okay, so now you have to go to the definition, what is conic section. Okay, so conic section. Okay, conic is defined as the cutting of a right cutting of right circular cone with different. Okay, cone is defined as a cutting of right circular cone with different angle related to the axis and base. Okay, so this is axis and this is base. Okay, so related to the axis, thus the base of the cone are known as conic section. So sometimes we have ellipse, parabola, hyperbola, and sometimes we have circle and point and straight line and inset line. Okay, so how this relative angle with the form with some angle related to the base and the axis, we can obtain parabola, hyperbola, and circle sometimes and straight line. Okay, so let's see how this our conic section further divided into ellipse, parabola, and hyperbola. And as I mentioned, the angle theta, alpha, beta, and phi, how much angle will be needed to form ellipse, parabola, hyperbola. Okay, so let's see the 2D view. Okay, just a minute. So next have to select, this is double circular right cone. In this case we have to select some cutting plane, so at different angle, so that we can for ellipse. Okay, this is the cutting plane. Okay, which got the double circular cone at different angle. Okay, so these are the axis. Okay, okay, so see how much the from base the cutting plane at angle. As you know, this angle is beta, and this generator to the base angle is alpha. Okay, and this is the semi-apex angle, it is theta, and from this axis the cutting plane makes an angle phi. So here we observe theta is less than phi. Okay, and beta also less than alpha. Okay, in this case this is our angle beta and this is our alpha. Okay, and this is our angle phi and this is our angle theta. Okay, so here in this case this end generator and the cutting plane angle are parallel, so that their angle will be same. So alpha is equal to beta, and as these are the parallel lines with each other, and also this baseline, sorry, this axis line will be cut at angle theta and alpha, theta and phi angle, so that they will be also equal. Okay, so theta is equal to phi. Okay, in this case and this is our alpha angle and this is our beta, and this is phi and this is theta, semi-apex angle. Okay, here theta is greater than phi. Okay, and beta is greater than alpha. Okay, so in this case this section, observe the cutting plane cut the cone at this portion, and in 3D view you can observe this section. This is called as ellipse. Okay, so at theta is less than phi and beta is less than phi, we obtain the section is after cutting is called as ellipse. Okay, understand? Okay, now in this section the cutting plane cut the section will be, this is the 3D view. After cutting you can find this curve. Okay, and this curve where alpha is equal to beta and theta is equal to pi, to obtain the curve is parabola. Okay, now when theta is greater than phi and beta is greater than alpha, we obtain, after cutting this cone by the help of this cutting section plane with this curve, obtain this called as hyperbola. Okay, Okay, this is ellipse, this is parabola, and this is hyperbola. Okay, this angle you have to remember. Beta is the angle between the base and the cutting plane, and alpha is angle between the generators and the base, and theta is semi-apex angle, which is make an angle generators with the axis, here the axis. Okay, and phi is the angle between the cutting plane and the axis. Okay, the curve after cutting you can just see. These are the this called ellipse. Okay, after cutting you can obtain this from the top view, you can see. Okay, these are the ellipse. Okay, similarly you can obtain the parabola. Okay, similarly you can obtain this is hyperbola. Okay, just imagine how you obtain. Okay, next discuss rectangular hyperbola. Okay, hence we can say that the section plane is parallel to the axis include. Okay, before starting rectangular hyperbola we have to understand what is asymptote. Okay, so asymptote is a straight line that continuously approaches a given curve that does not meet at any finite distance. Okay, so see this line and this line doesn't meet and they are parallel to each other. So this line is called asymptote of this curve. Okay, so rectangular hyperbola is such case in which the asymptote is obtained. Okay, as the lines are parallel to their respective curve. Okay, so rectangular hyperbola. Okay, when section plane is parallel to the end away from the axis and its included angle between the asymptote is 90 degree, then the hyperbola is called rectangular hyperbola. Okay, so see what is the difference between a hyperbola and rectangular hyperbola with example. Okay, see this angle is 2 theta. Okay, and this is our axis, and this is our cutting plane or section plane. Okay, which got the double cone axis, double cone. So here 2 theta does not 90 degree. Okay, and here 2 theta is 90 degree. This is our axis. This is cutting plane or section plane which cut, and this curve obtained by this section, this is called rectangular hyperbola. Okay, and this is normal hyperbola. Okay, this is rectangular hyperbola when the apex angle is 90 degree. Okay, as usual the formula is uh, theta is greater than phi and beta greater than alpha. Okay, the main difference is from rectangular hyperbola to sorry, and the main difference between hyperbola and rectangular hyperbola is, in case of rectangular hyperbola the 2 theta is 90 degree and the hyperbola 2 theta is not 90 degree. Okay, so rectangular hyperbola is a special case of hyperbola. Okay, next our topic is degenerate conic. Okay, so what is degenerate conic? Okay, when a section plane passing through the apex, then degenerate conics are formed. Okay, as you know what is apex, just in the first slide we see these are the apex, and when the cutting plane which passes through this point is the cutting plane is just go through this apex point, we just form a degenerate conics. Okay, so write the definition. When section plane passing through so write clearly. Okay, when section plane passing through the apex, then in the section plane passing through the apex, then degenerative conics are formed. So okay, so in this case just see the ellipse case, parabola case and hyperbola case. Okay, this cutting plane passing through the when just see. Okay, this cutting plane when passing through, sorry, this cutting plane and passing through this apex point, we get the curvature point. Okay, in this case we obtain the curvature point, and when this is as this is in parabola case, this is cutting plane and this end generator are parallel to each other, and when this passing through this apex, and this is always a straight line. Okay, this form a straight line. Okay, and in hyperbola case it will be become a intersecting line. Okay, this line will be just form between this and this, and this will form a intersecting line. Okay, so write down ellipse becomes point, parabola becomes straight line, 3 hyperbola becomes intersecting line. Okay, okay, this is the theory portion. Complete the ellipse, parabola, hyperbola. Okay, next a special case of hyperbola. When a section plane passing through the apex of the solid cone and intersecting the base, then we have a triangle. And triangle is a special case of hyperbola. Okay, so we have to just remember triangle is a special case of hyperbola. Okay, now when section plane passing through the apex of the solid cone and intersecting on the base, then we have a triangle form. You see how triangle is formed with the help of hyperbola. See, this intersecting line touches the base and thus form a triangle. Okay, so uh, next in next class we just find how to uh, obtain the ellipse, parabola and hyperbola with the help of eccentricity. Okay, this is very important. And what is the directrix, principal axis, vertex and focus, and definition of ellipse, definition of eccentricity with the help of ellipse, and some formula related to ellipse. Okay, and in the next class we just complete the chapter conic section. Next we go to projection. Okay, so thank you.